In today's lesson, we'll be learning about surface area of composite figures. In a previous lesson, we learned that surface area is determined by finding the area of each face and adding them up. As you can see here, a square-based pyramid includes a square, which is determined by length times width, and 4 triangles, which is determined by base times height divided by 2, where B represents the base of the triangle and H represents the height, and height must make a 90-degree angle with the base. In our first example, we need to find the surface area of this composite figure, which means I need to find the area of each face and add them up. I'm going to start with this face, which appears to be a square. The area of a square is determined with the equation length times width, both of which are the same. So 13 times 13, which is 169. However, this face is repeated several times. Over here, on the back, on the side, and on the bottom. Therefore, I'm going to take 169 and I'm going to multiply it by 5, which becomes 845 feet squared. Next, I'm going to focus on this face. This face appears to be a triangle. I don't have any dimensions for this triangle, but if this is 13 feet, that would mean this has to be 13 feet as well. We also need the height of this triangle. However, finding it is a little bit more difficult. Let's just look at this square-based pyramid separately on the side. I've gone ahead and separated the square-based pyramid from the composite figure. We want to figure out the height of this triangle. To do that, you'll need to see a right triangle within this square-based pyramid. That's a little bit difficult to do. So I'm going to draw that on the side. We're trying to find this, but what about the bottom of this triangle? The bottom of this triangle would be half of 13 feet, which would be 6.5. At this point, you can use Pythagorean theorem to find the hypotenuse. We're going to use the equation a squared plus b squared equals c squared. I'm going to replace some of these variables with their known values. I'm going to replace a with 13. I'm going to replace b with 6.5. And c stays the same since that's what we're looking for. At this point, you want to do the exponents before addition. So 13 to the power of 2 is 13 times 13, which is 169. And 6.5 to the power of 2 is the same thing as 6.5 times 6.5, and that is 42.25. I'm going to simplify the left side of the equation by adding these. So 169 plus 42.25 is 211.25. At this point, you should realize that 211.25 is way too big to be the hypotenuse. Therefore, we need to square root the right side of the equation because that is the opposite of squaring something. And what you do to one side of an equation, you must do to the other side of the equation. The square root of 211.25 is approximately 14.5. And 14.5 is a lot more reasonable than 211.25. Therefore, the height of this triangle is approximately 14.5 feet, and we're going to make use of this later. Now that we have the dimensions for this triangular face, we can use the equation base times height divided by 2. The base would be 13, the height would be 14.5. We want to multiply before dividing. 13 times 14.5 is 188.5. We're going to take that and divide it by 2. Which becomes 94.25. However, this triangular face is repeated over here, in the back, and in the back here as well. Therefore, I'm going to take 94.25 and I'm going to multiply it by 4, which gives me 377 feet squared. Now that I have the area of every single face, I can add them up to find the surface area of this composite figure. I've gone ahead and done that for you already. Therefore, the total surface area of this composite figure is 1,222 feet squared. When finding surface area, it is important to remember that you do not count any overlapping faces. Therefore, I am not counting the face that is between the square-based pyramid and the cube.